Hello, Glendale Community College students. We are on our last chapter 10 video. This chapter, we've been talking about the mole. And this is our last video, so we're going to talk about empirical and molecular formulas. Now, you already know what a molecular formula is, like water is H2O, ammonia is NH3, salt is NaCl. Magnesium bromide is MgBr2. So those are molecular formulas. So a molecular formula shows you the actual number of atoms present in the compound. So it's real. It's how many atoms are actually in that compound or molecule. An empirical formula is just the smallest whole number ratio of those atoms. So it's like you reduce it down to its smallest ratio, like when you reduce a fraction. So it's just giving you a ratio of the atoms to each other. Now, in some cases, the molecular formula can't be reduced at all, so it's already the empirical formula, like water, H2O. That can't be reduced anymore. H2O has a 1O in there. You can't reduce one. It's already the lowest whole number there is. So H2O is the empirical formula for water as well. But now think about hydrogen peroxide, H2O2. That can be reduced down, right? The 2-to-2 ratio can reduce to 1-to-1, HO. So hydrogen peroxide's molecular formula is H2O2, but the empirical formula is H1O1 because we reduced it down. We divided 2 by 2 to get 1. Okay, here's another example right over here. The molecular formula for glucose is C6H12O6. Can that reduce down? Yes, it can. So the empirical formula will be different. What can you divide all those numbers by to get the smallest ratio possible? You can divide them all by 6, right? So that would give you C1H2O1 or CH2O. That is the empirical formula for glucose, CH2O. You divide each element by 6. So that's what an empirical formula is. All right, what are we going to do with this? Well, we're going to learn how to write an empirical formula from the percent composition that we just learned how to do. So we just learned how to do percent composition. So there are 4 steps to doing this. Step 1, you assume the total mass is 100 grams. That way the percents turn into grams. Number 2, you use the molar mass for each element to convert from grams to moles. So we know how to do that. Again, grams to moles, moles to grams, you use the molar mass. Molar mass is the mass in the periodic table. All right, step 3, you're going to have these ratios of moles. We're going to divide each by the smallest number of moles so we get whole numbers. Number 4, round the whole numbers if they're really close, like 3.95 would round to 4. Okay, and then you write the empirical formula. Now, if any of the numbers are not close to be rounding, like if we had 2.5, that's not close enough to round to 3. It doesn't round to 2 either. So we would need to multiply 2.5 by 2 to get it to 5, which is a whole number. So you just multiply everything by a small integer to make all the ratios whole numbers. We want whole numbers in our empirical formula. All right, so we got these 4 steps. Let me show you an example first. All right, we have percent composition data. A compound contains 40.05% sulfur and 59.9995% oxygen. 59.95% oxygen. What is the empirical formula? Okay, step 1 was we're going to assume 100 grams of this SO compound. So that means we have 40.05 grams of sulfur and 59.95 grams of oxygen. Now, let's change grams to moles. Step 2, 40.05 grams of sulfur, change to moles using the molar mass of sulfur. Again, all you have to do is find sulfur in the table. There's 32.07 grams of sulfur in 1 mole. The grams goes on the bottom, so grams will cancel out top to bottom. So we've got grams of sulfur canceling out. We got moles of sulfur left as our answer, and it's 1.249 sig figs, 1.249 moles of sulfur. Now we have 59.95 grams of oxygen. Again, an O is 16.00, not 16, 16.00 grams in that mole. Grams is on the bottom, so grams will cancel out. We changed our grams to moles, 3.747 moles of oxygen, 4 sig figs. Okay, so now we have our mole ratio, but the moles are not whole numbers, so that's hard to see what the ratio is. So step 3, divide the mole ratios by the smallest mole number. Okay, out of those two numbers, 1.249 is smallest. So we're going to take 1.249 moles of sulfur divided by 1.249, which is 1.000, right? It's exactly 1. And then we take the 3.747 moles of oxygen divided by the 1.249, which gives us 3.000, so 3. Now we have whole number ratios, 1 and 3. So what's our empirical formula then if we have 1 S and 3 O's? You're right if you said the empirical formula is SO3. Good job. Okay, so again, we have our 4 steps to get to our empirical formula SO3. Rewind and go through this again if you need to. All right, so watch this one again probably because you're going to need to do this. All right, let's try another one. Here we go. We have our percent composition data. We have a compound. It contains 25.94% nitrogen and 74.06% oxygen. So it's an NO compound. What is the empirical formula? Okay, this is where you hit pause and work this on your own because you're probably going to have to do one of these on an exam. So you need to be able to do this on your own. Hit pause. Okay, we're back. Step 1, assume 100 grams. So we have 25.94 grams of nitrogen and 74.06 grams of oxygen. So we have our grams. Step 2, convert to moles. 25.94 grams of nitrogen. There is 14.01 grams of nitrogen in a mole right there from our periodic table. The grams goes on the bottom, so it'll cancel out. And we're left with 1.852 moles of nitrogen, 4 sig figs. Now the oxygen, 74.06 grams of oxygen. Find oxygen in the periodic table. You probably know this one by now. It's 16.00 grams per mole. Grams is on the bottom, so it'll cancel out. We get 4.629 moles of oxygen. Good job. We have our mole ratios now, but they're not whole numbers. So step 3, divide the mole ratios by the smallest mole number. The smallest number is 1.852. So for nitrogen, we get 1.852 divided by 1.852, which is, of course, 1.000. That's 1 mole of nitrogen. Now for oxygen, we take 4.629 moles of oxygen divided by 1.852, which ends up being 2.499, so 2.5. We can't round 2.5 to 3. It's not close enough. So what are we going to do to get whole number ratios here? We have a 1 to 2.5 ratio. We're going to need to double both of them, double them. So multiply by 2. That will give us 2 N's and 5 O's. That's our empirical formula, N2O5. Again, rewind this and watch it again if you need help. You're going to need to be able to do one of these on your exam. Again, these are empirical formula calculations. And that's actually it for chapter 10. Lots of math in this chapter. I know it's pretty long, but you can do this. Watch the video segments again if you need to. Do the worksheet, practice problems. Good luck. Bye-bye.